is able to estimate the difference of objects in space, knowing that Earth is on a course around the sun. So what they do is they measure the star's movement against the background of more distant stars over the course of that movement around the sun. And by looking at that difference, they can get a better idea of exactly how far apart those things really are. A good kind of cheap and dirty way to play with this method is the same way that, have you guys ever done this where you have obviously one dominant eye and you can test which eye is dominant? If you hold your finger over something in the distance, you close one eye and your finger stays in the same spot. You close the other eye and the finger seems to jump a little bit.
Yeah,
that's very similar to what we're talking about with parallax. We have to be able to triangulate that difference to know exactly where your finger is because your eyes are in two different positions to be able to figure it out. The cool thing about parallax, I think, and what Steve brought up too, is parallax's relationship to parsec. So let's first talk about the etymology of parallax. It's from Middle French parallax from the 1570s, which goes back to the Greek parallaxis before that. It refers to change, alteration, inclination, and even before that, you can kind of break it down into para and elasi, which is, also Greek, which means to change. Similarly, when we look at the word parsec, which you guys know what a parsec is, right? That's a unit of measure.
3.26 light years, parallax second.
There you go. And that's the thing. When we think about astronomers and how they actually talk, they don't usually use years that often. They actually talk in parsec.
Well, not even parsecs really. I would say you hear things like megaparsec, gigaparsec, really vast distances
That's true.
in space.
Yeah, so just like you said, Bob, a parsec is a unit of measure for interstellar space that's equal to 3.26 light years. It's the distance to an object having a parallax of 1 second as seen from points separated by one astronomical unit.
That's a good way to put it.
That's really where the word comes from. It actually was first coined in 1913, and if you break down the word parallax in second and you take the first syllable of each, it becomes parsec, which I think is so cool. And I'm not sure
it's a cool word. It's just a cool
know
word.
about that connection.
And do you know, Kara, why they use AU as the reason?
The astronomical unit? I'm not sure. Why would they use
Earth's
that?
orbit, right, Steve?
Earth's orbit, because what we're
Yeah, there you
doing
go.
is looking at stars at one point in Earth's orbit and then comparing their positions when observed at a time of the year when the Earth is at a different point in its orbit. So basically we're using the movement of the Earth around the Sun to generate the parallax.
And so just like the genius that is the metric system, it's always system. It's always easier when you base it on kind of that single unit of one.
And for close stars, you could then make a really skinny triangle, and you could actually find the distance very, very accurately. And unfortunately, that only works for very close stars, because once you get a certain distance away, then the parallax is so tiny that you can't even measure it. And then you need standard candles, and that's where the standard candles come in, like Cepheid variable stars and supernovas, which gave us the expansion of the increasing expansion of the universe. So
parallax is good to about 100 parsecs, which is about 326 light years. That's about it. Beyond that,
so tiny,
too tiny to measure. Yeah. Well, Bob, speaking of clever astronomers, some astronomers have made an interesting prediction about something we should be seeing in about 5 years. Tell us about that.
Yeah, it's not just interesting, it's unprecedented. An unprecedented prediction that they claim that a binary star collision will create a nova in the night sky in 2022, which will appear as a new naked eye visible star. And so the two big takeaways here is that this prediction has never been successfully made in the past, and this is going to be a naked eye star. I mean, you could see new stuff and really cool stuff in a telescope all the time, but the stuff that you could see naked eye, that's really amazing stuff that everybody can see just by looking up in the night sky, as long as they don't have too much light pollution. This prediction was made by astronomers at Calvin College University in Michigan. The forecast was made officially at a press conference, which is kind of ironic that this happened, I think, on the day of the Epiphany, which apparently commemorates the visit of the three wise men who supposedly followed the new star of Bethlehem. So that was kind of an interesting coincidence there, the new star. So apparently this new star is being called the Boom Star. Boom, baby. Sorry, I just saw the Emperor's New Groove again. So binary star... Yeah, that is such a damn good movie. So the binary star system is named KIC 9832227. There's that creativity. Thanks, guys. It's about 1,800 light years away. So it's not really close, but it's not very far. Close enough. So it's a binary star system. The separation is incredibly tight. It's an 11-hour orbit around one another. These two relatively low-mass stars, and it's not an ordinary binary either. This is called a contact binary, meaning that they are actually sharing a stellar atmosphere. Some websites are comparing it to a peanut, but they do share their stellar atmosphere, which is really cool. You've probably seen pictures of it. It kind of looks like a dumbbell type thing. If they do collide, and if and when, I guess, it will create what's called a red nova.